before we start writing today, just a few definitions, I need to go over a few things from yesterday. So, faces is the 2D shape or shapes that make up the entire shape. Okay? Edges is where we have two or more faces that meet. Okay? And vertices is where we have three or more faces that meet at a point. We could also call them the corners. Yep.
Isn't it 4, 8, isn't it just 2?
Or 2, sorry. What did I say? 2 or more? Yeah, just 2. Yeah, for the edges. Yeah. Thanks, guys. Okay, so tell me on this cube, how many vertices does this shape have? Vertices. You know them as corners too, but we'll use the mathematical terminology. Yes, we do. A big one.
8.
8, great. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, how many faces does this cube have? And then what shape are they too? Sean? Not 8? 6, yeah, and they are what in this shape? What shape are they?
Squares.
Right, and this shape just has one type of 2D shape as its faces. They're all squares. How many, I'll hold it really still for you, and this is where visualizing becomes really important. How many edges does this shape have? I'm Duffy. 12? 12, good. So it's got 1, 2, 3, 4, and then 4 on top. 1, 2, 3, 4, and 4 on the bottom. Okay. We also talked today about nets and how some of them can have a couple of different arrangements that would work as the net of a shape. And the net is what? Who can describe what a net is in terms of 3D shapes? Yes, Lily? Great. So if I was to fold a 3D shape out, it would be the faces that are all connected. And if I was to fold it back again, it would become my 3D shape. So with this cube, if I was to have these two wing parts lower, it would still technically work as a net because I would be able to fold it correctly. But, just a sec, did you go to the toilet? If this was over the other side, here, it would overlap and so it would then not be the correct net in that arrangement. Yes?
A better description of a net is where 2D shapes get put like 2D shapes, say, combine to make a 3D shape, so you roll them up and they make like some massive 3D shape from 2D small shape.
Yeah. So that's a good point Archie's saying, is that they do need to be connected if you were to draw these. So you couldn't draw me 6 squares that weren't joined together. That would not be a net, that would just be 6 squares. Okay? Has anyone got a shape that's got different faces there? So for my hexagonal prism, which this is, we've got different shapes. We've got a series of rectangles, 6, and then we've got 2 hexagons on the side. Again, if I move these down both together, or if I had one there and one there, would that still work?
No?
I don't see why not.
Yeah. Actually, yeah, it would, wouldn't it?
If this was up here, would that work?
No.
Okay, because it wouldn't fold.
No.
Okay, it's a bit like tessellating in terms of that there needs to be no overlaps and no gaps. Okay, so what I need to go through with you today, I didn't realise I was up there too.
Oh, I'm not on screen.
Recording this.
So, yeah. Sometimes you can write in your books or your exams or that table we did yesterday, F, E and V for faces and for vertices, that's fine. Okay. So the 2 things that we need to take away from today is what is the difference between a prism and a pyramid. Okay? I threw those terms around earlier today. I didn't really explain them, and that was on purpose. So, Jake, can you just put that back in the container for me? Next one. We've got a pyramid here. Okay, and it is a hexagonal pyramid. Cool. And then I've got a prism. Okay, I'll show you back. That's the same situation, yeah. And then I've got a prism here. So let's have a close look. What do you think the difference is? Boys at the back? What do you think the difference is? TK? Yep. Tell me more information about that. You're right. Yeah, good. So squares or rectangles, quadrilaterals, fantastic. Regular ones, but yeah. Cool. So the way that I remember these is we've got our pyramid, which reminds me of a pyramid in the fact that it has triangular sides that come to a point and then a different face on the bottom. Unless it is a tetrahedron, in which case the triangle will be at the bottom still. What were you going to say? Not quite. Yeah. And then a prism has the same face on the ends, and in between it will have either rectangles usually or squares. So the way that I remember, sorry, I was going somewhere with that. Pyramid looks like a pyramid because it has a point at the top, or a vertex at the top, but the triangles join. A prism, and I was thinking about this, how we could remember a prism. Prism sounds like prison, as in jail, and this could look like a prison cell compared to that. Is that helpful?
Yeah.
Okay, you can also think of a prism as if you were to slice it like you would slice bread or a cake. It would be the same shape all the way through, wouldn't it? Whatever it is on the end. So in this case, it would be hexagon shapes all the way through. Okay, but if I was to slice this one, it would be different sizes. Okay, but this is the same size shape all the way through. Is that helpful? Yeah. Okay, let's write these definitions down. So just reading through these notes on the board. A prism, two of the same 2D shape on the ends with rectangles or squares connecting them. If you sliced it, the shape would be the same size and it looks like a prison. Maybe like a Harry Potter prison. And a pyramid, one 2D shape as the base connected to triangles that meet at a vertex. When sliced, the 2D shape would be different sizes and it looks more like a pyramid. So there are different types of prisms and pyramids, and they're named usually based upon this type of 2D shape. Yes.
Would you could either, when it says one 2D shape as a base connected to triangles that met at a vertex, wouldn't that be meat? Or you could just get rid of that?
Yeah, sure.
And also just saying, describing what a pyramid looks like by saying it looks more like a pyramid is just sort of saying like, tell me definition of the.
Yeah. It's not perfect, but I'm trying to make sure there's enough things for people to remember it by.
Okay.
Okay. Okay.